So in this video I wanted to talk about the applications of exponential equations. We already talked about the idea that an exponential equation in general looks like this, where a is the initial value and b is the growth or decay factor. We also talked about the fact that growth rate, if we call that, say, R, there's a relationship between growth rate and growth factor. So if we call growth factor B, that means B is always equal to 1 plus R. And if you're talking about decay, if decay rate was represented as R, then B, the decay factor, would be 1 minus R. So, for example, if I say that I have $2,000, whoops, that's a funny looking dollar sign, $2,000, and deposited in a savings account that pays 3% a year. So in this case, that 3% would be a growth rate. It's growing every year. So the initial value would be $2,000. The B, or the growth rate, would be 3%, otherwise known as 0.03 if it's the decimal equivalent. And so therefore the B would be 1.03 because it's 1 plus 0.03. And then we put a little t up here, and we'd say is t is measured in years. T is measured in years. How do we know it's measured in years? Because it says it's the savings account pays 3% a year. Okay? So we could use this equation to find, say we want to know how much money is in the account after 10 years, if I don't add anything else to it. So we'd say y is equal to 2,000 times 1.03 and raised to the 10th power. So you can see we can create a little equation that we can use to predict how much money is going to be in my account at that time. Let's see, that would be 1.03 raised to the 3rd power times 2,000. And that would be $2,185.45. Okay. Or let's say that we have 200 water striders in my backyard pond. And with the cold, they are dying at a rate of 5% a week. Okay, so that 5% is a decay rate because we'd be going down. So our formula would be y equals 200, because that's the initial value of water striders, and this would be 1 minus 0.05, because b is equal to 1 minus the decay rate. And we'd raise that to a t, and we would say t is measured in weeks. Right? So that'd be my equation. So in other words, y equals 200, times 0.95 to the t. So that'd be equation. So if I said how many bugs are left after 7 days. Okay, now this is where you got to be careful. So I'm giving you the information in different units than you want, because we want to measure t in weeks, right? So if I want to know how many bugs are left after 7 days, I would say y equals 200 times 0.95, and I'd raise that to the first power, because there's in 7 days there'd just be 1 week. So then we're just going 200 times 0.95, which means there'd be 190 left. Okay? So what if I want to know how many in, say, 15 days? Okay? So that'd be y equals 200 times 0.95. And basically what we do is take 15 divided by 7, right? Because we know there's 7 days in a week. So we want to find out how many weeks there are in 15 days. So we just divide 15 by 7. So then we would go 0.95 raised to the power of 15 divided by 7. And then multiply that by 200. And we get 179.182, and then our common sense tells us, of course, there's no such thing as a 0.182 water strider. So we'd say there's 179 striders left. So the key is looking at the rate, converting that to the B, or the growth factor, and then also pay attention to the units, because depending on how they quote your growth rate or growth factor to you determines the units you'd use for your time. Because generally this up here is going to be a time unit.